So let's extend this story now, and what if I give you this situation? Mod of x plus mod of y is equal to 3. Okay, so the story is now the story now looks different, but I have a very stable, tried and tested tool. What is that? Playing with input output and trying to capture the value. That is how you will be able to handle any story given to you. Not the teacher cannot create every possible story, right? Like in a limited duration period as such. Now I'm thinking, why can't a teacher create? But ignore that. How do I learn to handle something like this by myself? That is the main game. I already know how this graph looks and what are the points. I can just draw it quickly and say, okay, just draw it like this. But how would one discover it by themselves, right? Especially if they saw it for the first time. So I'll start playing. I say, okay, x is 0. I put a 0 here. So you will require some problem solving here. I put a 0 here. 0 plus mod of y is equal to 3. Okay, so mod of y is equal to 3. Quickly, what can be the value of y? 3 or minus 3. That's the whole game in modulus. You get two values, right? So when x is 0, y will be 3 or minus 3. Okay, how do I plot this on my Cartesian coordinates? If x is 0, y is 3. If x is 0, y is 3. So let me plot it here. When x is 0, y is also minus 3 or could be minus 3. So let me plot that as well. Great, I have done the plotting. Let's see what happens in the next step. I say x is equal to 1. If I put x is equal to 1, I'll get a mod of y is equal to 2. That means y will be equal to 2 comma minus 2. Okay, so when x is 1, y is equal to 2. So I'll plot it so. When x is equal to 1, y is equal to minus 2 as well. So I'll plot it so. So maybe now I see a line kind of happening. Continue with the story. If x is equal to 2, now guessing should be faster. Y will be equal to 1 comma minus 1. So when x is equal to 2, y will be equal to 1 comma minus 1. This is not drawn according to accurate scale. And when if I make x is equal to 3, y will become 0. If x is 3, y will become 0. Do solve it for yourself. So when x is 3, y has become 0. When x is 3, y has become 0. So I'm building a graph like this. What have I learned so far? That I should not only think of the positive values of x, I should also think of the negative values of x. So if x is minus 1, how will the story work out? If x is minus 1, mod of that will still give you a 1, mod of x will still give you a 1, and therefore mod of y will be equal to 2, just the way it was when x was equal to 1, and the values of y will still come out as 2 and minus 2. Please repeat the steps very clearly. No step should be missing. There should not be any feeling of uncertainty. If I say this is minus 1, mod of that will give me a 1. This will become plus 1. So my equation will be 1 plus mod of y is equal to 3. I will remove the 1 and this will become mod of y is equal to 2. And if mod of y is equal to 2, y can be 2 or minus 2, right? So just a little extra step. And I see, okay, this is not making a difference. Okay, so when x is minus 1, y is equal to 2 and minus 2, right? The same story being played out. Maybe let me draw it slightly wider. Okay, x is equal to minus 2. If I put a minus 2, this comes out as 2 only. That means the solution will be the same as when x was equal to 2. So learn to use every little observation in your process and don't be stuck to a method, right? So I see that at x is equal to minus 2, y will be equal to 1 comma minus 1. So 1 comma minus 1. So now I see the graph. I can now extrapolate, play the game also fully. So my graph will look something like this. And now on top of this, if I have this idea clear, I can create a question around it. I can say, okay, what is the area of this region? I hope you figure that out by your own method as well. Or you can create this triangle and add up their areas together. So the second challenge is not a challenge at all. The clarity is here, whether I understand how the graph will appear in such a situation. Let me play with this story. Mod of x plus mod of y is equal to 5. Once again, if I catch on to the patterns that I know, this doesn't make too much of a difference. Yes, maybe the size will change, but the shape will remain the same. I've seen enough repetition of patterns, right? So I already now know the pattern for mod of x plus mod of y is equal to something. You can put a here and figure everything out, right? So in case that is troublesome and you doubt the process, again create the table. When x is equal to 0, y mod of y will be 5. So y can be 5 or minus 5. Put it on your Cartesian coordinates. If this is 0, this will be 5. If x is 0, it will be minus 5. So these are the 2 points. Now think quickly. If this is 5, y will become 0. If the output is 5, the output here will become 0, right? 5 plus 0 will give me 5. But the output can be 5 for both minus 5 as well as 5. So think of this point. When it is 5, when x is equal to 5, y is equal to 0. Okay, now just connect the two lines, right? Now just connect the 2 points. Connect the points. And the other point will be minus 5 comma 0. What is this point? 0 comma 5. What is this point? 0 comma minus 5, right? Be very clear about your coordinates. And then just connect it. So you can also create a table. I leave that for you. Okay, great. So now I see that the moment I look at a function like this, now I can also memorize the shape and then start playing with it, right? Let me add one more challenge here. I will not solve it myself. I will leave the challenge for you. If I change the story and I say this is less than 5, mod of x plus mod of y is less than 5, how many integer solutions for this inequality, right? That means how many xy pairs satisfy this equation, this inequation or inequality. And what do I mean by that? So once again, let me first think of the equal to 5. I know this is the shape or the region for equal to 5. This story is telling me less than 5. That means points inside this region. So any point inside this region, any integer inside this region is going to work for the story. Okay, so now let's start playing with that. How many integers in this region? So now let's start playing with that. How many integers can I spot in this particular box? So again, let me start with the x-axis. Can I use minus 5 and 5 because it said less than 5? If I put x is equal to 5, y is equal to 0, I'll get equal to 5. So 5 is not okay. But what would be okay? X is equal to 4, y is equal to 0. So I'm going line by line. How many integers on this line? And again, you won't have to write it down. I say, okay, this point is acceptable, this point is not. I'm looking for integers only. Nobody will ask you about all possible numbers, right? Because that would be infinite. What would be the next point? 3 comma 0. This is also on the same line. This whole line is y is equal to 0. So I will have a 4 and a 3 and a 2 and a 1 and a 0, 0, right? Okay. So on the right side, I have 1, 2, 3, 4. That means on the left side also I will have a 1, 2, 3, 4. So I have a 4 and a 4, 8 and 9. So just on this line, I have 9 solutions. What the solutions are? You can put your finger anywhere and ask. This is going to be 1 comma 0. Put 1 comma 0. It will be less than 5. So it works for me. So I go line by line. That is my step number 1. Go one step ahead. Think of the next horizontal line. You could have also done the process vertically. Think of the next horizontal line. What does this mean? This whole line is y is equal to 1. You were at y is equal to 0. Now I am thinking about y is equal to 1. Let me go step by step again. What is this point? This point is y is equal to 1 and x is equal to 4. But at this point, the total will become 5. So is this point okay? No, this point is not okay. Similarly, would this point be okay? No, this point will not be okay. Think about what is the location of this point anyway, right? Okay. What is this point? What is the point in the middle? It is 0, comma 1. And 4 is not allowed. So 1 will be allowed, 2 will be allowed, 3 will be allowed, 4 is also ruled out. Again, 1, 2 and 3 on the other side, 4 is ruled out. Okay. So I got 9 solutions. In the very next line, how many am I getting? 3 on one side, 3 on one side, 6 and 1 in the middle. I'm getting 7 solutions. Is there a pattern? Yes. In the next line, can I detect a pattern here? because then my thinking will be slightly faster. The next line, first of all, what is the next line? Y is equal to 2. So how many solutions will I get? I will get 5 solutions. My next line will be y is equal to 3. How many solutions will I get? 3 solutions. I'm just reducing by 2 in each step, right? My next line is going to be y is equal to 4. I'm just extending the logic. How many solutions there? 1. My next point is going to be y equal to 5, but is that point allowed? No, this point is not allowed because I have to remain less than 1. Okay, so 9 plus 7 16 plus 5 21 plus 3 24 and 1 25. So my total comes out as 25, but that is only for this region, right? I should also think about this region, and some of you might be going in your heads that okay, for this region I found 25, so this region also I will find 25, which you can do 25 plus 25, but remember this line is common to both, you have already counted it. So do 25 plus 25, but after that subtract the 9 solutions. So I'm getting 50 minus 9, my answer should be 41. What is equal to 41? Number of solutions for this inequality is less than for this inequality is going to be equal to 41. So the game can be complicated and somebody can ask you more things also. Find only the integers in this region. What if this equal to is allowed? Then the points I had eliminated, that x is 5, y is 0, x is minus 5, y is 0, even that will be included. So instead of a 9, I'll have a 11 solution. Instead of a 7, I'll have a 9 solution, and so on and so forth. So challenges can be increased, but all of them can be tried out once you understand the basic diagram of this. And then you understand in detail that okay, I'm talking about coordinate. Each coordinate has two values, x value, y value. These are points on the story. Basically this thing you have to, that's why I keep recommending use of graph paper, because once there is clarity there, it's very difficult to lose it even if the graph is not present, right? So in a question like this, that how many integers satisfy this condition, each of these points, right, on the line, I mean if there is an equal on the line will also be okay, is a solution in the story, right? Keep drawing the grid. I'm not doing it to scale or accuracy, I'm just trying to show that each of these intersection points is a solution. So you just have to count the points, and then even for that, if I think systematically, I say okay, this how many here, I take the first step with just pure logic and maths. In the very next step, I find a shortcut, and then I double the idea and then I work it out, right? But as of now, I'm only thinking about playing with this graph, not too many things as such.